So now we're talking about absolute value functions. We've talked about absolute values before in the definition of an absolute value, but now we're going to look at the graph. To start off with, I actually want to look at the graph of y equals x. Now if you think about that, the y-intercept is 0. Let me make this a little bit bigger here. The y-intercept is 0, and it looks like the slope is 1 over 1. So we graph that point, and we fill that in, and then we have it going down here, and so we have this graph that is basically at a 45-degree angle, top to bottom. Alright, now we're going to compare that to y equals the absolute value of x. If you think about that, whenever you plug in a negative x value, you're going to get a positive y value. So if we plug in, let's say, a negative 1, we get the absolute value of negative 1, which is a positive 1. So when we plug in a negative 1, we get a positive 1. If I plug in a negative 2, I get a positive 2. Negative 3, I get a positive 3. And so what happens is we've got this graph that goes up this way, and then when I plug in a positive 1, I still get a positive 1. So the green graph is the graph of an absolute value. It's like a V. And then this time, if I look at the slope here, it's down 1 to the right 1, so my slope is negative 1 here, but a positive 1 here. Alright. Now, if you remember, we did piecewise functions a little bit ago. And so basically what's happening, if we compare it to the graph here, if you look at the graph, if x is bigger than 0, it's just x. It's just the graph x where it crosses at 0 and it goes up 1 over 1. If it's smaller than 0, then our slope is negative 1, so the graph would be negative x. And if x is exactly 0, then we're at 0. If you think of it, you plug in 0, you get 0 as a graph. And the last thing I want to point out on this page is that the corner is a vertex. So here, remember, we've got this V, this right here, that point right there at the corner where it changes direction is called the vertex. Alright, so you guys, if you want to, you can check this out. I think you might have a graphing calculator on your iPad, or you can get a graphing calculator on there. We'll actually spend some time in class with graphing calculators looking at this. But what happens is I'm going to do a black line for the XY axes. I'm going to use a blue line for y equals absolute value of x, so it'll be right here. It goes up at a 45, up at a 45 there. Alright, now if you were to plug in to your graphing calculator using the absolute value function, if you were to plug in absolute value of x plus 2, let's see here, you would get something that the vertex is right there. You would get the exact same function, but the graph would be up 2. So let's think about y. If I made a table here, and let's say I plug in a value of 1, well, the absolute value of 1 is 1. The absolute value of 1 is 1, plus 2 gives me 3. So instead of my y value being at 1, it is now at 3. So instead of it being at 1, it's now up here at 3. Sorry, I lied. We're talking about this point right here. It's now up here at 3. If I plugged in 0, absolute value of 0 is 0. The absolute value of 0, 0 plus 2 gives me 2. And that's going to be that one at the vertex. So every y value that you would have gotten when you are looking at the absolute value, every y value would have gotten is the same there, but then plus 2. So every point is up 2. If I did the other one here, where I had the absolute value of x minus 2, I'm going to have every y value is 2 less, and so it would look something like this. So the moral of the story is, if you add a number, outside of the absolute value, it moves it up that many units. And if you subtract a, it moves it down that many units. we call the absolute value of x, just a simple absolute value of x, nothing added or subtracted, is called the parent function or the base function. It's our original function that we graph, and then we move it according to what we're doing out here. All right. Then we have to talk about what happens if you add or subtract inside the absolute value. So here's what goes on. Again, I'm going to graph y equals the absolute value of x. Okay, that's our usual one. If I set up a table, I'm going to get going on this table again. Okay. Now, if you actually plug this in your calculator, it's actually kind of weird what happens here. Alright, so if I plug in 0, I get the absolute value of 0. And then I get the absolute value of 0 plus 2. 0 plus 2 is 2. So, let's see here. If I plug in 0, I get 0. X is 0, y is 2. Okay, now you almost feel like it might be like the last time. But now let's plug in 1. I get 1. Here I'm going to get 1 plus 2, and I get 3. So now if I plug in 1, this was at 1, now it's going to be at 3. Let's go with negative 1. Then I would get 1 here, which you can tell because we went back up again. Over here, if I plugged in negative 1, I get 1, and the absolute value of 1 is 1. So if I plug in negative 1, uh-oh. It's no longer going up. It's actually, what's going to happen is, now my vertex, instead of being at the origin, is going to be over here at negative 2. And so my graph is going to go like this. And so what happens is, if you add 2 on the inside, it actually moves to the left 2, which is kind of counterintuitive that it goes to the left 2. I'll leave it to you to think about why that might happen. If I go with the other one, this minus 2 here, my vertex is now going to be at a positive 2. And so if I subtract inside the absolute value, it actually moves us to the right, which is kind of strange. And then the next one is what happens if I change the number in front of the absolute value. Now I'm not talking inside the absolute value, I'm talking about in front of the absolute value. And what happens is, just like the number in front of x, it becomes your slope. So if I graph this, oops, didn't mean to do that color. If I graph this, xy axis, the parent function of x, let's make that in blue again, it looks like this. Okay, now if I do 2x, I'm going to do that one in green. What happens, instead of my slope being up 1 over 1, it's going to be up 2 over 1, and so all of a sudden it becomes steeper. If I made my slope 1/2, instead of going up 1 over 1, it's going to go up 1 over 2, and it's going to make it shallower. And then over here on the left side, this would be negative 1/2. And for the green one, it's going to be negative 2. Okay? And then for these negative ones down here, for negative x, it's going to be just like the blue one, it's going to be flipped upside down. So then here I have negative 1 for a slope, and over here I have a positive 1. So the slopes are going to be the same, just the opposite sign. And then let's see here, for the negative 2, it's going to be a pretty steep one going down. So this one would be negative 2, and this one would be a positive 2. So again, you can plug all those in a graphing calculator and see it for yourself, but let's try graphing a couple of these. Now, what I do when I graph is I first start thinking about my vertex and where does that belong. According to this, the minus 3 means it's going to go down 3. So I'm going to take it down 3. And then the negative 2 means I'm going to go to the right 2. Remember, that's the opposite of what you think it's going to be. So my vertex is going to be down 3 to the right 2. So this is actually going to be my vertex. So then if I want to do my slope, notice there's no number in front of x, so my slope is still going to be 1, so I go up 1 over 1. And so on this side of the line, or this side of the graph, I'm going to go this way. And then on the left side, it's going to be -1, so I go up one to the left one so that I get my v here. And this is the graph of this one right here. Alright, let me erase that and go to the next equation here. Okay, looking at this one now, let me go to a different color even. My vertex, it looks like it's going to go up 1, and then it has a -1, so I'm going to go to the right one. So I go up 1 to the right one. So here's my vertex right here. Now my slope has a negative there. So for my slope, it's going to be a -1 on the right. So I go down 1 to the right one. So this is going to be an upside down V. And then for the other side, it's going to be a +1. And there we go. There's my graph of that one.